Alright guys, this is for Math 2. It's our first lesson, just kind of a review and maybe some new stuff about functions. First off, we kind of define and talk about what a function is, and we know that it's a relation in which the domain value is paired with exactly one range value. Okay? In other words, what we're trying to say is the domain are always your x's, ranges your y's, so the x's never repeat. They don't repeat. There's a couple ways to determine whether an whether a relation is a function or not, and that's by using a map, or we're talking about sets, or we're talking about graphs. So we're going to look at maps first, and I've got two maps for you here that have domains and ranges. We look at the first map here, and what I want to do is I ask myself, hey, does my domain A, is it paired with exactly one range? And it is. The A is paired with a 2. I ask myself the same question for everything. Is B paired with 1? Yes, B goes to the 1. C is paired with the 2. And D is paired with the 3. Now, notice every domain was paired with exactly one range. It's okay that the range repeated here. On the bottom, it's the other way around. I've got the -8 for the domain goes to one range. The -1 goes to one range. The 0 also only goes to one range, but here's a problem. The 15 of the domain is trying to go to two different ranges. So the 15 is not paired with exactly one range, and that's why the bottom one fails. I want to think about this a different way too. I want to think about it like a vending machine. Alright? So I'm going to say that I've got Sundrop, Pepsi, and Mountain Dew. Okay? Let's go through the same process. If I press the letter A on my machine, what does it give me? It gives me a Pepsi. If I press the letter B on the machine, it gives me a Sundrop. If I press the letter C on the machine, it gives me a Pepsi, which is not unusual. A lot of times there's two different buttons on a machine that'll still give you the same drink, so that's not unusual. And if I press the letter D, it'll give me a Mountain Dew. So this vending machine is functioning, there's the word function, it is functioning correctly. Now I'm going to come down here and think about the same thing. We'll call the 7 a Mountain Dew and the 9 a Pepsi. Alright, if I press the letter 8, -8, the machine will give me a Mountain Dew. If I press the number 1, the machine will give me a Pepsi. If I press the number 0, the machine will still give me a Pepsi. But if I press the number 15, here's the problem. What drink will it give me? And the answer is, I don't know. It might give me a Mountain Dew, it might give me a Pepsi. But that's not a good machine. So obviously this machine is not functioning correctly. And that's why the first one is a function and the second one is not a function. Now, we can look at it the same way just by looking at sets. Of course, we know from last year in previous classes, I could take all of these numbers and these ordered pairs and I could rewrite them as a domain and a range. So I could rewrite this just like these maps if I wanted to, but I really just want to do it a faster way. Does this 2, if I press a 2, what number comes out? A 3. Does it ever happen any different? No. If I press a 4, I get a 5. If I press 7, I get 3. If I press 1, I get -4. Each one of those domain values, the 2, the 4, the 7, and the 1, consistently give me one answer. And that's why this one is, yes, a function. Alright? But on the bottom, when I look at these, if I press -3, I get a 3. But what happens right here? If I press a 4, I get a 1. But over here, if I press a 4, I get a -6. How can I get two different values? How can I get two different values when I press the same one? Okay, and that's the problem. That's why this one is not a function. Because these two 4s are trying to give me two different answers. One of them is a 1, one of them is a -6. In other words, they repeat. Working. I'm recording my lesson.
Oh, I see.
And now you're on my lesson.
Oh, am I?
Yeah.
I don't want to be on your lesson.
Well, you signed the waiver at the beginning of the year. You're on it.
I did it,
You did.
actually.
I'm used to having having three classes. I can do it twice, and then the third one I can actually just record during class.
Yeah.
But now it's only 2 and 1,
Oh.
so
So it's shaky.
I don't know if I want to record it the first time I do something.
All right.
But then it takes me 5 or 10 minutes to get one done, and then it takes 5 or 10 minutes to load to YouTube. Sometimes it goes immediately, sometimes it don't. But we'll see you, Randy. Come by and get some help if you need some. But, it's Randy. Who's in my advisory? Is he my advisor? Created a relationship. He's in my 4th grade. He stays every day. I taught his older brother.
Who's his older brother?
Um,
Go ahead.
his older
say.
brother was,
Couldn't tell you.
his name was Michael Matthewson. I got in a shouting argument with his father on the phone in the hallway back in the other part of the building
Interesting.
when I was teaching.
You never told me about that.
Wasn't even parts. Wasn't
Louise
even
Felix, please come to the office.
It was
Louise
like-
Felix, please come to the office.
pre something. I mean, there was no curriculum.
That's interesting, because you never tell me about this, and
Oh,
I
yeah.
believe. Shouting argument, huh?
Oh yeah, it was.
Why is your screen so beat up?
Why
You
is
do a lot of this?
I point to stuff all the time.
Well, it's
Well, occasionally I point with a marker. by
dirty
mistake.
and gross.
Well, I touch it.
It's because you're dirty and gross.
It's because I touch it. I really need to finish this. It'll take forever. It'll just take forever. I'm already stuck against the wall because I'm a wall hugger because it ran out of juice. So I had to finish 4th period today. I said, I'm sorry, but I have to sit here and finish this because I knew it was going to die. Had already gone from 10 to 5%.
I have to stay doped up.
Okay.
It's the only way I feel like a...
And again, as you can see, that one single x value actually gives me 2 different y values. So of course this one is no, not a function. Okay, the next thing we talked about with functions are whether they were discrete or continuous. The biggest thing we did was we really just looked at these examples and we said, hey, what's the biggest difference? And the biggest difference is discrete, all these dotted graphs, whereas continuous has a smooth line. They're connected, and that is a huge difference between discrete and continuous. Discrete will be dotted, and continuous will be connected. Now, discrete ones are when you're trying to count something. Okay? It's some sort of counted number for your domain. For example, you can tell down here, sometimes age is a counting number. Tickets is a really good example, and customers. And here's the biggest difference. Can you have 2.5 tickets? And of course, the answer to that is no. You can't sell 2.5 tickets. You can sell 1 ticket, or 2 tickets, or 3 tickets, but you can't sell 1.5 tickets. And that's why these are not connected, because all of the fractions and decimals in between these don't count. Okay? And that's the case for all of these. This example here with customers. If the first customer gets 2 samples, and the second customer gets 4 samples, and the third customer gets 6 samples, you can't have 3.5 customers, so the fractions don't count. So it's a counted number for discrete. Now, if the fractions do count, we call it continuous. And continuous means there's an infinite number of domain possibilities. In other words, an infinite number of x's that you can put in. Okay? So, for example, when I'm measuring pounds right here, well, I could have 1 pound, and I could have 2 pounds and 3 pounds, but I could also have 1.5 pounds. And they will charge me. This one's about pounds versus cost. So maybe you're mailing something at the post office. If it cost, or maybe you're buying something in the grocery store. You know, bananas cost per pound. So If you have 1 pound, it costs this much. If you have 2 pounds, it costs this much. But it's possible to have 1.5 pounds, or 1.2 pounds, or 1.23478 pounds. In any case, all of those little decimals count. Same thing for temperature and degrees. You know, you can have, the temperature doesn't just jump from 70 degrees to 72 degrees. It has to go through all of those itsy bitsy little decimals first, 70.1, 70.2. So that makes it continuous, and that's why you continue to connect those dots. Not a lot to talk about here with independent and dependent. We can get into some things, but basically I just need you to know that independent values are always your X, or your input, or your domain. Those all mean the same thing. And your dependent value is always your Y. Okay? So when you're graphing something, the independent value will always go on your horizontal axis, and the dependent value will always go on the vertical axis. Alright, and then finally for function notation. Alright, function notation. If we evaluate a function, that means that we're going to plug in input to get out output. Now I know that sounds redundant, but some people don't know what input and output means. So if you plug it in, it's called input. If you get it out, it's called output. So the way I read function notation, of course, is f of x. F of x. And what it means is evaluate the function at the value of x. For example, down here, I'm going to evaluate this function at x is -3. So I plug in a -3. Of course, you guys can see when you plug in a -3. You can use your calculator or just do the math. You end up with +3. On this second example, same thing, same idea, but just being careful. I'm going to plug in g of -4. And of course, you have to plug it into both x's. So that looks something like this. Notice I'm using parentheses. And especially in your calculator, make sure you use parentheses, because a negative times a negative gives you a positive. You end up getting 8. Alright, and then the last one I want you to look at is, see the way this is written, h parentheses 5? That doesn't mean h times 5. It means h of 5, just like this was f of x. This is h of 5. So of course the 5 gets plugged in for the x. So I'm going to write that out as 3 times 2 to the 5th power. And again, follow your order of operations. And you end up with, oh, I forget what it is, 96.